This is the Mandelbrot set, one of the most famous images in mathematics. Zoom in forever and you'll never hit bottom. The same shapes just keep echoing smaller and smaller all the way down. And this is a black hole, a place where the laws of physics basically throw up their hands and quit. Two completely different objects. One's an equation, one eats stars for breakfast. So why do some physicists and some not-so-physicists think they might secretly be the same shape? The claim that sounds insane. Here's the theory in its wildest form. A few independent researchers, outside mainstream academic physics, have proposed that black holes aren't just described by fractal math. They are structurally fractals, specifically shaped like the Mandelbrot set. The argument goes like this. Black holes show up at wildly different scales, stellar mass, supermassive, hypothetically even microscopic, and they all look and behave the same way, just scaled up or down. That's called self-similarity. And self-similarity is basically the Mandelbrot set's entire personality. Zoom in, zoom out, same patterns forever. One version of this idea even relabels the black hole's event horizon as the boundary of the set, the fuzzy line between trapped forever and escapes to infinity, which weirdly is also a pretty good description of what the Mandelbrot boundary actually does mathematically. And look, I'll admit it, squint hard enough, tilt your head, maybe don't sleep for 2 days, and yeah, it kind of tracks. This is the point in every conspiracy documentary where they show you a grainy photo and go, coincidence? I think not. So let's actually check. Here's the catch. This idea hasn't been peer-reviewed. It's mostly published on preprint sites that don't require review and presented at conferences built for alternative physics, the academic equivalent of a bake sale where nobody checked if the ingredients were food. That doesn't mean the people proposing it are dumb or that self-similarity in nature isn't real. It means cool pattern matching, not yet a theory. But here's the twist. Real, rigorously tested, peer-reviewed physics does connect black holes and fractals, just not the way you'd expect. The turn. Forget the Mandelbrot set for a second. What actually generates fractals in nature? Chaos. Not chaos like your group chat before a birthday party. Chaos in the mathematical sense. Systems so sensitive that a microscopic nudge at the start completely rewrites the ending. And it turns out the space right around a black hole is one of the most chaotic environments physics has ever modeled. The real science. Picture a charged particle drifting near not one, but several black holes at once, say 4 extreme black holes locked in a static configuration. Physicists actually modeled this, and what they found is that the particle's path becomes chaotic, shift its starting position by a hair, and it might escape to infinity, or get violently flung back, or spiral in and vanish. Now here's where it gets interesting. If you map out every possible starting position and color code the outcome, escape, capture, fling, you don't get a clean, sensible boundary. You get something that looks unmistakably like a fractal. Physicists call this a fractal basin boundary, and it shows up again and again in these calculations. I know. Fractal basin boundary sounds like something you'd get sued by an energy drink company for trademarking. Stay with me. The same thing happens with light. Researchers studying binary black holes, 2 black holes orbiting each other, found that photons passing nearby can get caught in an endless dance, orbiting one, then the other, then back again in patterns that never quite repeat. Map out which photons escape and which get swallowed, and the boundary between them isn't a simple line. It's shaped like a Cantor set, a fractal built by infinitely removing the middle third of a line over and over forever. So when astronomers eventually image a binary black hole shadow, the dark silhouette against glowing gas, the edge of that shadow mathematically should have fractal structure baked into it, infinitely fine detail if you could zoom in forever. Okay, deep breath. Let's recap because I just threw 4 different kinds of fractal at you like a dealer at a very nerdy casino. Fractal basin boundaries, from particles bouncing chaotically between multiple black holes. Strange repellors, chaotic, unstable orbits that trap things temporarily before flinging them out, studied even for things like cosmic strings looping around a black hole. Cantor set shadow boundaries from photons chaotically orbiting binary black holes. And separately, the Mandelbrot set, which is its own mathematical object, born from a totally different equation that just happens to look like its cousins with all of the above. None of these are literally the Mandelbrot set, but they're all made of the same ingredient, chaos, iterated over and over until it draws a border too intricate to ever fully trace. That's the real headline. Not black holes are secretly the Mandelbrot set. It's chaos itself has a signature, and that signature is always a fractal, no matter what system it shows up in, whether pendulums, heartbeats, galaxies, black holes. Different equations, same fingerprint. Why this actually matters. Here's why this isn't just a cute visual coincidence. When physicists find a fractal boundary in a chaotic system, it's not decoration, it's information. The fractal dimension of that boundary literally measures how chaotic the system is. A perfectly smooth boundary means predictable behavior. A jagged, infinitely detailed one means good luck predicting anything, even in principle. So next time you see a black hole shadow image and it looks like a clean, simple, dark circle, remember that somewhere in the math generating that image, at scales no telescope will ever resolve, there's a fractal structure fighting to get out. The universe doing what it apparently loves to do, taking simple rules and iterating them into infinity. And the fringe theory? It's not crazy exactly. It's more like someone spotted a real pattern. Self-similarity shows up all over physics and jumps straight to therefore literally the same shape, which is a bit like noticing your dog and your grandpa both like naps and concluding they're the same species. So, are black holes secretly the Mandelbrot set? No. But are they and the space around them drawing fractals of their own using the same chaotic logic that built this one? Genuinely, yes. Which raises a much bigger question. If chaos draws fractals at the edge of a black hole, where else is it quietly drawing patterns we haven't noticed yet? Next time we're going looking.